Now I'm going to be doing trigonometric identities. There are basically three identities which are very important. The first one is sin square theta plus cos square theta is equal to 1. Second one is 1 plus tan square theta is equal to secant square theta. And third one is cot square theta plus 1 is equal to cosecant square theta. Now let's derive these identities. So for that we are going to be drawing a triangle, right angled one. Right angled at B. So this is B, this is C, and this is A. We're going to take ratios of A. So now we have, by Pythagoras theorem, we have that AC square is equal to AB square plus BC square. Now dividing all of these equations by AC squared, we get AC squared by AC squared is equal to AB squared by AC squared plus BC squared by AC squared. AC squared plus by AC squared is equal to 1. AB squared plus AC squared, which is adjacent by hypotenuse, is equal to cos theta plus opposite by hypotenuse, which is sin theta. So since there is square, it will become sin cos square theta, sin square theta. So this is how we derive the first one. In the second one, what we do is, now we divide everything by AB squared. So we get from this thing, AC squared is equal to AB squared plus BC squared. Divide everything by AB squared. You get AC squared by AB squared is equal to BC squared by AC squared, BC squared by AB squared plus AB squared by AB squared. Now AC squared by AB squared is hypotenuse by adjacent, which is secant square theta. So you get secant square theta is equal to BC squared by AB squared. BC squared by AB squared is opposite by adjacent, which is tan theta, and here, since it's squared here, it's tan square theta. AB squared by AB squared will be 1. So you derive the second one. Now the third one is cot square theta plus 1 is equal to cosec square theta. Now let's write the Pythagoras theorem again. Now this time we'll divide it by BC squared. We get AC squared by BC squared is equal to AB squared by BC squared plus BC squared by BC squared. Now this is AC squared by BC squared is hypotenuse by opposite, which is cosecant square theta, and AB squared by BC squared is adjacent by opposite, which is cot theta. Since it's squared here, it becomes cot square theta, and BC squared by BC squared is equal to 1. So plus 1. That we have derived all the three identities. Now here are some other useful ratios with identities, so it's going to help you out in some problems. First is sin 2a is equal to 2 sin a cos a. Let's take a as 45. You get sin 2 45, 2 into 45, and we get sin a is sin 45 is 1 by root 2, and cos 45 is also 1 by root 2. So 2 into 1 by root 2 into 1 by root 2 is equal to 1, and sin 90, as we all know, is 1. So we have verified the first one. Now let's take cos 2a. Let's take a to be 30 degrees. So cos 60 is 1 by 2, cos square a. So you get root, this will be 3 by 4, since root 3 by 2 whole squared, and sin square a. So sin a is 1 by 2, and sin square will be 1 by 4. So you get 3 by 4 minus 1 by 4, which is 1 by 2, and we have verified this second one also. Now let's take tan 2a is equal to 2 tan a by 1 minus tan square a. So let's take let's take a to be 60 degrees, or let's take a to be 45 degrees. We know that tan 90 is not defined, so not defined. 2 tan a, 2 tan a is 1 by 1 minus tan square a. So tan 45 is 1, so 1 minus 1 0, and since anything divided by 0 is not defined, we get not defined implies not defined. So hence we have verified the third one also. These fourth and fifth one won't be of any use most of the times, but when you're solving higher level problems, it's going to be a boon. So we have cos of a plus or minus b is equal to cos a cos b minus or plus sin a sin b. This implies that if it is cos a plus b, then it will be equal to cos a cos b minus of sin a sin b. And if it is cos a minus b, then it will be cos a cos b plus sin a sin b. We're not going to be verifying this, as it won't be of any use in NCERT syllabus. And the next one is sin a plus or minus b is equal to sin a cos b plus or minus cos a sin b. As you can see from the previous one, if it is sin a plus b, you get sin a cos b plus cos a sin b. There's a difference here. Before it was minus and now it's plus. And if it's sin a minus sin b, sin a minus b, you get sin a cos b minus cos a sin b. We're not going to be verifying this also. Okay, now we're going to be doing problems based on identities. We will solve the first one. First one is cot theta minus cosec theta plus 1 by cot theta plus cosec theta minus 1 is equal to what? For this, we have the identity, one of the three basic identities, that 1 is equal to cosec square theta minus cot theta, cot square theta. If you factorize this, you get 1 is equal to cosec theta minus cot theta into cosec theta plus cos theta, cot theta. Now, if you transpose cosec theta minus cot theta to the other side, you get cosec theta plus cot theta is equal to 1 by cosec theta minus cot theta. Substituting 1 in the equation, we get cot theta minus cosec theta plus 1 whole by 1 by cosec theta minus cot theta minus 1. By taking LCM, we get cot theta minus cosec theta plus 1 by 1 minus cosec theta minus cot theta whole upon cosec theta minus cot theta. This and this cancel since they are the same, and this will go up. So this will become cosec theta minus cot theta. So this is the answer for the first one. Now we are going to be solving the second one, which is sin theta and cos theta are the zeros of ax square plus bx plus c is equal to 0. We need to prove that a square minus b square plus 2ac is equal to 0. Now we're going to start this by using one of the theorems from polynomials, as we have uploaded before. So we get the sum of the zeros of a quadratic, which is sin theta plus cos theta, is equal to minus b by a. And we have sin theta into cos theta is equal to c by a. Now since there's an identity related to sin theta plus cos theta, which is sin square theta plus cos square theta is equal to 1, let us square the first equation. This is the first one, this is the second one. squaring 1, we get sin square theta plus cos square theta plus 2 sin theta cos theta. Since this is a plus b the whole square formula, you need to, many people just miss out this sin theta cos theta, so be careful about that, is equal to b square by a square. Now we know that sin square theta plus cos square theta is 1, so transposing 1 on the other side, we get 2 sin theta cos theta is equal to b square minus a square by a square. Since minus 1 will come here, by taking LCM you get b square minus a square by a square. Now transposing 2, we get sin theta cos theta is equal to b square minus a square upon 2a square. This is third equation. Okay, now since the LHS of third and the second one is equal, by Euclid's geometrical statements, we can say that b square minus a square by 2a is equal to c by a. So b square minus a square by 2a square is equal to c by a. Cross multiply, we get a into b square minus a square is equal to, by taking 2 out a out common, you get 2 into a into c. 2a square c, a into 2ac is 2a square c. So I've just taken out a common so that I can eliminate a. So we get, and transpose this to this side, we get b square minus a square minus 2ac is equal to 0. If you take out negative out common, you get a square minus b square plus 2ac is equal to 0. And hence, like this you can solve trigonometric problems.